All right, now we're going to learn how to use trigonometry to calculate unknown angles. So we've used it to calculate unknown sides, so now let's use it to calculate unknown angles. We already know that all the angles in a triangle add up to 180 degrees. So again, pretending that we were in something like, say, NAPLAN, if we were given two angles, here we know we've got 90 degrees. We know that because the little corner is marked out. Again, don't assume unless it's marked out. We know that all we need to do to work out this little missing angle up here is to say that x equals 180 minus 90 minus 27. So let's cheat and do it on the calculator. 180 minus 90 minus 27, it's 63. So the missing angle, x equals 63 degrees. Terrific. But what happens when you can only identify the right angle? So if you didn't know this one, how would you work out this one? And that is where trigonometry comes in super handy. So once again, let's give ourselves a little reminder. Very important to label a triangle to start with, just so we remember it's all about relationships between sides and angles. So opposite the 90-degree angle, that's where you'll find the hypotenuse. This time I'm going to drop in a real angle as my reference point. I'm going to drop in 30 degrees. And I know that the side that is opposite 30 degrees is called the opposite. And that the side that runs adjacent to 30 degrees, the one that's left over, is the adjacent. So once again, just remembering SOHCAHTOA. So sine, and this time I'm going to say in relation to this 30 degrees equals the opposite over the hypotenuse. Ka is the cosine, this time again in relation to 30 degrees, and it's the adjacent over the hypotenuse, the adjacent divided by the hypotenuse, and TOA is the tangent 30 degrees, and it is the opposite over the adjacent. Now it's really important that we remember that these relationships, when we've got the angle, that the sine of 30, the cos of 30 degrees, the tangent of 30 degrees, these are fixed numbers. So let's have a little look again, just quickly remembering. Don't look at that one for 3 seconds because it'll come up in a second. But before we even start, remember you need shift, mode, and number 3 for degrees whenever we're working with sine, cos, and tan. So do I have my little D turned on? Yeah, yes I do. So let's have a little look here. I'll just pop that there so that we can see it. I'm going to find out what is the sine of 30 degrees. It's 0.5. So whatever lengths my opposite and hypotenuse are, if my reference angle is 30 degrees, when I divide the opposite by the hypotenuse, I'm going to get 0.5. We've already found out how to do that to find missing lengths. Let's do it for the cosine. Cosine 30 equals, okay, let's round this to 6. It equals a super close approximate to 0.866. Terrific. And now let's look at the tangent of 30 degrees, and it equals 0.77 because 3 is less than 5, so that stays the same. A very close approximation to 0.577. Excellent. So, just like I could use these numbers and these relationships to work out missing lengths, I can use, basically, I can do this in reverse. And I can do this in reverse by using the inverse of that relationship. So I'll just show you what I mean by that. Essentially, if the sine of 30 degrees is 0.5, then the inverse is sine to the power of -1, and this time I pop the result in to get the degrees. So let's have a little look at that. I realize that the sine of 30 degrees equals 0.5. Sorry that light's shining on it. I hope you can see that. So to work out 30 degrees, when I know the sine, I type shift sine, and this time I'm going to put in 0.5. So I know that if I'm dividing the opposite by the hypotenuse and I get 0.5 and I want to find out what that angle is, I divide the opposite by the hypotenuse to find this angle. So I do that and I get 0.5 and I want to find out what 30 is. I do that by typing in sine, so shift sine is sine to -1. Then I type in the result of the opposite divided by the hypotenuse and I get 30 degrees. So essentially it's working out the inverse. It's using that relationship between the sides to find the angle. So let's just have a little look. Let's just practice using those inverse buttons. So once again, a quick reminder, just check that you're in degrees. It's shift sine is sine to the power of -1. Shift cos, cos to the -1. Shift tan, tan, the tangent to the power of -1. All right, let's just practice using our calculator for a second. If you know that the sine, the opposite divided by the hypotenuse, if it gave you 0.53, so you divided your opposite by your hypotenuse and you got 0.53, and now you want to work out the angle, the relevant angle. You want to find out that reference angle. So I'm going to go shift sine, because I want sine to the power of -1, and I type in 0.53 to find out the inverse. And I get essentially 32 degrees, or what is, sorry, I won't move that like that, what is very, very close to 32 degrees. Let's work this out. So the cosine, the adjacent divided by the hypotenuse. Just say I've divided the adjacent by the hypotenuse and I've got 0.37 and I want to find out that reference angle. So shift, sorry, all clear. Why did I turn that off? Shift cosine, so it's cosine to the power of -1. Then I type in the inverse. And I end up with 68.3 degrees. Something, sorry, I don't know why I keep moving that, very close to 68.3 degrees. Now for the tangent. I know that the tangent is the TOA, is the opposite divided by the adjacent. Just say I've done that sum and I've ended up with 2.14, and now I want to find out that reference angle. I do the inverse. So to find the reference angle, it's, sorry, why am I doing that? I'm going to go shift tangent to find the inverse. I know, again, the opposite divided by the adjacent came to 2.14. So the reference angle is going to be super close to 65 degrees. Really very close approximation to say that the reference angle is 65 degrees. So it's working it out in reverse. So let's have a look at it, how it might look in a question. So if I wanted to find this little angle here, again, I start by naming them. Great. I've got a hypotenuse, just like I did with the unknown lengths. And I've got an opposite. Beautiful. So when I've got a hypotenuse and an opposite, I'm going to just quickly remember what involves that. So hypotenuse, opposite, great. I'm going to be using sine. So I know that the sine of x is going to equal the OA, opposite, over the hypotenuse. 11.5 divided by 16.2. So what do I get? 11.5 divided by 16.2, I end up with, I'm going to go with 0.71. I end up with a super close approximation is to say 0.71. So now I know the nature of that relationship, I can work backwards. And I can say that sine, the inverse, sine to the power of -1, is going to give me that angle. So shift sine, the inverse of sine, being 0.71, equals 45.23 degrees. Something super close to 45.23. Therefore, x equals 45.23 degrees. Kind of cool. Hopefully you could see that. I'll move the little camera down and over a bit and we'll have a look at this one. Again, it all starts with labeling. So across opposite my 90-degree angle, I've got an hypotenuse. Here is my reference angle that I'm trying to find. So there's my opposite. I don't have anything, but I do have, I've got this little one, I've got an adjacent. So I'm going to remember SOHCAHTOA. I've got an adjacent and a hypotenuse. Cool, I'm going to use cosine to work this one out. Adjacent over hypotenuse. So if I know that the cosine of that angle y is going to equal the adjacent 21 over the hypotenuse 25 equals, what is 21 divided by 25? 21 divided by 25 is 0.84. So now I just need to work out the inverse. I nearly said invoice. Inverse of cosine 0.84 equals shift cosine 0.84, close my brackets, equals something super close, 32.8, let's go with 86 degrees. Something really close to 32.86 degrees. Therefore, y, to say y is a super close approximation to 32.86 degrees. Oh, sorry about that. You didn't see me type in that last bit. There we go. It was just about doing the inverse. So the details that I had was an adjacent and a hypotenuse, and I know that I can use cos when I've got that information because cosine is the adjacent divided by the hypotenuse. So I did that sum and I ended up with 0.84. So now I needed to work out the inverse. If I know that the inverse of 0.84 is it's super close approximation to say 32.86, then y, this little angle here, has got to be super close to 32.86 degrees. Excellent. Not really a surprise what the final one's going to be, but let's do it anyway. So, again, we begin with the labeling. Across from my 90-degree angle is my hypotenuse, and I don't have anything. So this is the angle that I'm trying to find. This is my reference angle. What's across the road from it? 13 is the opposite, and 9 is going to be the adjacent. If I've got the opposite and the adjacent, can I do so? Nah. Car. Nah. Toa. Yep, because I've got the opposite divided by the adjacent. So I know that the tangent of z degrees is going to be equivalent to OA, opposite, divided by the adjacent. What does that equal? 13 divided by 9, 1.444444. Let's just go 1.44. 1.44. It is super close to. It's not exactly equivalent, it's super close to. So, if I know that that is 1.4444, the opposite divided by the adjacent, then I know that the inverse of tan to the power of -1, the inverse of tan is going to equal 1.44. And I can just type that in. Shift tan 1.44 equals 55.22. It is super close to 55.22. And 50, so therefore, Z, super close, 55.22 degrees. Excellent. I just really quickly want to point out here that, very much like when we did negative indices, another way to work this out from here, when you get to this point here, is I don't need to work that out right from up here. I can simply substitute that into there. I'll just give you a little example. I can type in, I'll just write it here, shift sign, and then in my brackets, pop in 11.5, 16.2 straight away. Let's have a look at what I get. Shift, sign, and we said it was 11.5 over 16.2, close my brackets. Whoops, go right, and then close my brackets. So you see, notice that I used the fraction button, and I had to use my brackets, and I had to navigate right before I did that, and that equals 45.22. How's that? 45.224, 45.23. Excellent. So I can just do it that way. I can bypass working this out first. I just wanted to do it to show you the relationship. Let's have a go with this one here. I'm just going to go for the inverse of 21 over 25. The inverse cosine 21 over 25. Let's try that one. So shift cosine 21, fraction button 25, head right, close my brackets, equals 32.859, 32.86 degrees. Terrific. And again, let's just do that here with the tangent. I can immediately, rather than work out this step here, I can just inverse tangent 13 over 9. So let's go. Shift, tan, opposite, over, adjacent. And I get 55.30. That one is slightly different. So I worked it out the long way to show you the nature of the relationship so that you could see all we were doing was working backwards. All we were doing is working backwards from these terrific relationships. But you can skip a step if you want to. Excellent. I hope that's super helpful. Please don't forget to email me if you have any questions.